Welcome, everybody. It's good to see you. This is Unit 4, Lesson 3. So you're looking for tasks for U4L3 under assignments or on the weekly calendar. Today's date is January 11th. We'll start off with our usual pair share. The question for today is, what sport would you compete in if you were in the Olympics? Now, this could be anything. It doesn't have to be something you have experience with. It could be something you're interested in or curious about. But if you were going to be an Olympian, an Olympic athlete, what would you want to compete in? And I will tell you that between the Summer and Winter Olympics, they have an Olympic category for pretty much everything you can think of. They just approved breakdancing as an Olympic sport. So think about that for 20 seconds. And don't forget to say hi and check in with the person you're in the room with as well. We'll come back together in 2 minutes. Rooms are open. Everybody. Next on the docket is homework check. So looking good. You just had to make sure you completed our classwork from our previous class about carbon footprint analysis and how to curb your carbon footprint. And then there was the notes and reading quiz on the circulatory system, which is looking great. Seeing 13 attempts, 100% correct on each of the questions. Big takeaway was that the circulatory system is all about transport, right? Every inch of your body needs oxygen and nutrients and needs to get rid of waste, and it's your circulatory system that provides those things, that kind of service. So any questions or comments on the homework for today? Alrighty. Then what I want to do is pick up where I left off with our climate change slides. I feel like I didn't get to finish those. I'm going to share to my, oops, what? Oh, interesting. Wants me to install a plugin for the AirPlay. I feel like it worked before. Okay, I think we're good to go though. I'm also going to tell you a bit of a personal story relating to carbon footprint stuff. So let's see here. Okay, everyone's seeing the sun in the atmosphere. I need a verbal confirmation. Can't see you right now.
Yes.
Awesome. Okay, I think this is where we left off, right? We were talking about how what we call greenhouse gases are these gases that are actually able to capture and re-release solar radiation simply by their bonds kind of springing back and forth. And that's a good thing, right? We want greenhouse gases in our atmosphere to keep the atmosphere warm so that life can continue to exist. But we are drastically altering this. This is the famous graph. So you're looking at concentrations of carbon dioxide in the air, parts per million over time. This was all measured in Mauna Loa in Hawaii. And what do you notice about carbon dioxide concentrations from 1960 to about 2014 to 2015? What's happened?
They've risen.
Yes, and what's interesting is quite steadily, right? We have this fluctuation, which is seasonal, right? So in warmer months, it's a little higher. In colder months, it's a little colder. But even with that, there's been this sort of very even, very gradual increase. And this is most likely due to human causes, right? That maybe, yes, there's some natural stuff, volcanoes, that kind of thing, but it's not sudden enough, right? This is definitely a representation of increases in coal burning and car usage and other things that are releasing carbon dioxide. So the question is, what happened further back, right? Can we go back before 1960? And the answer is yes, actually you can. What they've studied is air bubbles trapped in glaciers. It's really cool. So they can go to the Arctic or the Antarctic where you have these giant glaciers, and everyone see there's sort of layers. You can just see these like little stripes there that are almost like tree rings. And so what they do is basically they core it, right? They take a pole and they dig it down in there. And then when you look at this column of ice, it's got these layers that they can carbon date that are from certain time periods, right? Like maybe 10,000 years ago or 100,000 years ago. And inside these layers are air bubbles. And they can measure how much carbon dioxide is present and what other gases are present in there and get a rough idea, once they've measured a few of them, of what carbon dioxide levels were like. And so this gives them a much larger time scale. So here's one going about 1,000 years back, looking at carbon dioxide concentrations. And again, you can see it was actually pretty stable. And then only after, again, the Industrial Revolution and increases in human population have we seen this drastic increase. But again, 100,000 years or 1,000 years is still a pretty short, tiny window compared to geologic time. So here is one based on, it's called the Volstock ice cores, which I guess are maybe from the Antarctic. I'm not sure, but this is going back 400,000 years. So that's a pretty significant amount of time. And as you can see in this situation, there have definitely been some fluctuations in carbon dioxide levels. The highest ever recorded was 300 parts per million. But here we are today at 400 parts per million, 100 parts per million higher than at any time in the last million years, is what they think. So that's significant. That's pretty crazy. Um, so let's talk about potential consequences of this. This graph is showing you temperature on this side in red. So the red line is representing average global temperatures. On this side, it's carbon dioxide concentrations. Carbon dioxide concentration is shown in blue with a blue line. And what I'm hoping you notice is that they definitely seem to correlate, right? So as carbon dioxide levels go up or down, temperature goes up or down. But once again, the trend breaks right here, where here's the maximum temperature measured, here's where CO2 levels are right now. So what's going to happen? Are temperatures going to creep this high? Because if that's the case, that's going to cause some pretty extreme climate change on our planet. And we are starting to see some major events. There are some people who claim this is not real, right? They think it's fake or that it's just part of a natural process. The key thing they point to is this idea of correlation versus causation. So a lot of people say, well, yes, it's CO2 and global average temperatures have risen and fallen together, but it's not necessarily because one is causing the other. And so here's kind of a silly example. Did you know that US spending on science correlates perfectly to suicides by hanging, apparently? So here's your US spending, here's your hangings, and wow, look at that. Boy, the more we spend on science, the more people hang themselves. So that's kind of worrying. Now, what I'm hoping you notice is that these two things obviously have nothing to do with each other. It's all about in how the scales are adjusted to make the lines look similar to each other, and then they're overlaid. So that would be correlation, not necessarily causation. However, I would argue that in terms of climate change, we are definitely seeing causation. There's a lot of scientific evidence showing the role that carbon dioxide plays in capturing solar radiation. We're seeing definite changes in average temperatures, right, by up to 4 degrees Celsius or down by 3 degrees Celsius, especially in the northern regions of our planet. So it's a little, definitely something we should be concerned about. So in terms of what you can do, we analyzed our carbon footprint, and again, across the board, everyone's biggest contribution was by far transportation. Be curious to see how that's been impacted this year. I think it's been mixed. I think some people, because of the pandemic and lockdowns, haven't been traveling as much. I think other people, because we're remote learning, are actually traveling more than they would because they're not locked into school and coming to class in a certain location. Personal purchases was by far the lowest, which I found kind of interesting too. And then we talked about with that CNN article about what you can do to reduce your carbon footprint. So if you want to stop contributing to potential rising temperatures, you can recycle more. You can go vegetarian for a little while. When it comes your time to buy a car, right, buy an energy efficient car, an electric car or a hybrid car. The big thing you can do is have one less child than you planned on having. That's pretty extreme. Not necessarily something that a lot of people would consider doing, but big carbon savings. The CNN article emphasized refrigerators, specifically refrigerators and air conditioners used to use chlorofluorocarbons and hydrofluorocarbons. These things were really, really bad for the ozone layer. They depleted the ozone. So they were banned in 1987. We don't use these anymore. But it's not like refrigerators or air conditioners went away. They just replaced those chemicals with what's called hydrofluorocarbon, HFC, which doesn't affect the ozone layer. But this molecule right here, picture it like CO2. It can capture heat in the atmosphere, but it's 10 times more potent, 10 times more capable of capturing solar radiation and then re-releasing it into the atmosphere. So this is not something that we want to have leaking out. And so this is why recycling your refrigerator was like the most helpful thing you could do to curb your contribution to carbon emissions, right? This is what we want to avoid because refrigerators that are dumped are going to leak out all those HFCs, and then those are going to contribute to rising global temperatures by trapping solar radiation. So the personal story I wanted to tell was about my experience in the Peace Corps. I think this is a time in my life that I probably had the lowest carbon footprint. This was right out of college back in 2008. If you haven't heard of Peace Corps, it's a volunteer program through the U.S. government. It takes young college graduates, or well, any people of any age. You just have to have a college degree, but it sends you overseas to countries that have requested volunteers for 2 years, and you work in either at education, agriculture, small business development, health, whatever. I was an education volunteer. I spent 3 years actually. So I was here from 2008 to 2011. This is called the Gambia. It's right on the back of Africa, right here. And I was placed in this tiny country. It's about the size of Connecticut. I was right there, about as far up country as you can get. Even Gambians consider that the boonies. I lived in a rural village. I taught in a rural village school. I lived with a host family. And so here's why my carbon emissions were so low at this time. I lived in a little thatch roof hut. There's no power lines or electricity, no running water. So automatically, I'm not paying any bills or anything like that or contributing to carbon in that way. I did have electricity to charge a phone and an iPod that I had. It was just a solar panel that I had on my roof, so the sun would hit this. And I had a wire that went down into a car battery that was inside my apartment, and then I could charge my phone and my iPod off the car battery. But that was my source of electricity, the sun. Cooking, there was no methane stoves, nothing gas powered. It was all just burning wood. And they would just get these big logs that they would kind of slowly burn down. This is a friend of mine during training. Water, again, there was no hydroelectric dams or nothing, pipes leading to your hut. Everything was done in open wells. Basically, well, this is a closed well. You had to whale on this little lever here, and it would slowly trickle out water. You'd fill up a bucket and carry that back to your hut. These are refrigerators. So these are clay pots right here. And what would happen is you'd fill these with water, and we learned about evaporative cooling. So water would sweat out of these and evaporate off, and that would cool down the water on the inside. So it wasn't like ice cold, but it was definitely cooler than the air outside. So that was actually really nice. And again, no hydrofluorocarbons or anything like that in use. It's just a clay pot that you fill up with water. For bathing water, I used an open well. This is not water I would drink because, as you can see, it was wide open. So you'd have like chickens that would fall down here and die, or bats. And anyway, so water would be nasty sometimes, but it was good enough to bathe with, at least get some soap in it, but nothing I would drink from. There were cars and gele-geles and buses and all that stuff, of course, but they weren't very safe. I was in a car accident while I was there. And so I just started to ride my bike everywhere. This was the one thing Peace Corps gave us, was these really fancy Trek bikes that were really tough. So I could like load things on the front and the back and on my back and ride over these really rough roads and get around. So again, no carbon emissions there really, except what I was breathing out compared to going in a car. All my food was locally grown, except for a couple things that were imported, but they grew coos and corn and that kind of thing right outside the village and carried it in. A lot of fruits were also available. Does anyone know what those are? What are those? You can get these here in the US.
Mangoes?
Yep, those are mangoes. Does anyone recognize this at all? This is called baobab. I feel like this was a kind of a health craze for a little while in the US. It's nice, very dry kind of fruit. Now, the real prize is, does anyone recognize that? Does anyone know what that is? Specifically pay attention to this portion right here. That, believe it or not, is a cashew. So if you guys like eating cashew nuts come in these little seed pods that are attached to a fruit. Not a lot of people knew that cashews actually had a fruit. It's very acidic, and not something that's widely marketed or used, but anyway, I used to like eating it a lot. And then there's a lot of gardening. That's how I get my fruits and vegetables. So again, I don't think I ever did the carbon footprint calculator at this time, but if I did, I'm sure I would be significantly lower than my current lifestyle. That's for sure. Questions or comments on that? And if you're curious about the Peace Corps, I'm happy to talk about it. I encourage everyone to consider things like that, assuming it gets up and running after this pandemic concludes itself. All right. So I want to move on then to some biology. Let's talk about how we as living things interact with the atmosphere and the air around us. So I want to start off with some fun facts about the human body. On the tasks to complete list, we are now on step 4. fun facts about human body. It's just a short Google form, 4 questions. You don't need to look anything up. This isn't graded, it's anonymous, but I just want to take your best guess on these questions. I'm going to time for 5 minutes, but hopefully we'll get done before then. So 5 minutes to work on fun facts about the human body Google form. Go for it. Let me know if you need help. Concrete, my bones break, the concrete doesn't break. And that's why I had to say assuming equal weights, right? So if you are going by weight, bones are 4 times stronger relative to the weight compared to, like, if you had a bone and you tried to make a bone out of concrete with equal weight, concrete bone would break a lot more easily. How much saliva will you produce in your lifetime? Enough to fill 2 swimming pools. Most of you got that. Try not to think about swimming in your own saliva. You can eat blank. The correct answer was zinc. Because your stomach acid is strong enough to digest it. I don't know about gold. I suppose you could digest gold. I have a feeling that's something you would poop out on the other end. But you can actually break down things like iron and zinc. Those are actually metals we need in our bodies for various functions. And how many gallons of blood does a human heart pump each day? It is 2,000 gallons. Now, again, I'm not saying that you have 2,000 gallons of blood in your body, not even close. But it's because the same amount of blood is cycling through constantly. Questions or comments on that? You can find a lot of videos like that, like fun facts about the human body online. So if you like that kind of thing, check those out. Okay, then what we're going to do next is an ed puzzle about the human circulatory system as review. It's about 13 minutes long with 5 questions. I'm going to time for 20 minutes, but hopefully we'll get done with that sooner. So I'll keep track of how people are doing on Edpuzzle. As usual, there's also an alternative Google form if Edpuzzle doesn't work for you. So 20 minutes to work on the human circulatory system Edpuzzle tasks to complete step number 5. Let me know if you need help. Go for it. All right, let's see how we did. First question related to the functions, specifically which of the following is not a function of the circulatory system, and indeed storing energy in the form of fat, not something circulation does. It contributes to it, but fat's usually stored in your bones, around your liver, and places like that, and all over your body, all around your organs. So it's all about transportation and repair. Those are the actual functions. Blood returning to the heart first enters a chamber known as, again, if you know your Roman history, it is called an atrium. Atrium is often where Romans would welcome guests into their little villas. It's the opposite of a ventricle, right? To vent, to let something out. That's where things get pushed outwards. Why do veins have one-way valves in them? Looks like most of you got that. It is because, yes, blood pressure is very low. This is why movement is really important, right? The more you move, you're helping your blood back towards your heart through the veins. This is why if you've ever taken like an 8-hour flight and just sat there, your ankles swell and your feet swell because your blood is literally pooling with gravity because you're not moving enough to help the blood get back through the veins. Blood pumped into the heart to all parts of the body and body tissues first travels away from the heart through this is called the aorta. It's the major artery going from the heart to all parts of the body. It's right on top of the heart. As far as I understand, you can stick your finger in it if it's severed, and then it branches from there. And the last question was, why does blood have a metallic iron-like taste? If you've ever been hit in the mouth or tasted blood before, it's because hemoglobin carries oxygen using an element iron. So you actually have iron in your blood. Pretty cool. Like there's 4 iron molecules per hemoglobin, and there's like hundreds of thousands of hemoglobins in every cell. So pretty crazy. Questions or comments on that? All right. Then the final thing, I know this can be very complicated. There's a lot of names and a lot of things hooking into other things. So what I find helpful is to make a summary drawing. So the last thing I'll have you do today is work on tasks to complete step number 6, summary of circulation. If you click on that, circulatory system summary drawing, it takes you an assignment that looks like this. And you have 2 options. I have written instructions that you can follow, or what I recommend is just click on this link here, refer to this example drawing, and here is what you should draw in your notebooks. So it's a nice little summary. We've got the heart, You've got the lungs up above, you've got the body down below, and you can label each of the major arteries and veins and the circuits and all that stuff. So this is something that when I taught biology, I would have my students jot down on their circulatory system test to refer to so they wouldn't get confused. It would be great if you have two different colors. If you have red and blue, ideally, but even if you don't have red and blue, if you can use like green and brown, that's okay. If you don't have two different colors, it's all right. I'm not going to dock points. You can just draw it with one color. But go ahead and take all time for 6 minutes to work on that. It'll roll over into homework, whatever you don't have done. We'll come back together when there's 2 minutes left.